Good morning, everyone. I hope your spring break's going well. This video is going to help us finish up chapter 11, so hopefully you will be able to do your homework without too much confusion. For class, my 1010 class, your homework is up right now for the first week of spring break, and class number 2, you voted to have your homework up for the second week of spring break, so that will show up on Sunday, and I will send out an email reminder to everyone. So what we're going to talk about for right now is the end of chapter 11, and here's where most of us stopped on the first class. My second class, you got a little bit farther on, so you can just fast forward if you want. But what I want to bring your attention to are all the equations on this slide that we're going to be grabbing and using for our proofs in the exercise that I have set up here. So we have our expenditure on the first equation. The income is equal to the GDP from our assumptions for the second equation there. We have our aggregate consumption function, and then our planned aggregate expenditures, which are things that the business chooses in January before the year starts, and consumers cannot engage in any unplanned spending. So here's our example. For any value of GDP, we're assuming that the planned investment is $500, so that's fixed. And we have our consumption function, which I've given to you in this example. You should be able to derive it by yourself, but consumption is going to be 300, which is our autonomous spending, plus 0.6, which is our MPC, times YD, which is our disposable income. So the steps that you're going to follow, you want to fill out a column of GDPs, find your I planned, hint that's fixed, and then find your disposable income, which is going to be equal to GDP, and then find your consumption, and then we can find unplanned investments. So let's try that. I have everything filled out for the next slide, so if you, spoiler alert, you might want to pause this, fill out the table from the slides, and then look at it. Might be a good idea. So if you want to, give this a pause now and give it a try yourself. So here we have our real GDP. We have a column on the far left of going up by 500, starting at 0, 500, 1,000, 1,500, etc. And then we can fill out the second column because we know that YD is going to equal GDP in this scenario. So we fill out the second column. I planned, we're going to switch to the fourth column, is fixed, and you can just write a column of 500s right down there. And then you have your equation that I gave you for consumption. Consumption is 300 plus 0.6 times your disposable income. And so we figure that out by saying, okay, well, if our YD is 0, then our consumption is 300. Move to the second row. If our YD is 500, what's our consumption? Plug it into the equation, we find 600. And then we fill out that whole column. And as you can see at the very bottom, you get to 2,400 whenever you have a real GDP and disposable income of 3,500. So now the very far right column is planned aggregate expenditures. And we know from our equation that planned aggregate expenditures is consumption plus planned investments. So you just grab each of those two columns number 3 and 4, and we're going to add those up. And you see the planned aggregate expenditures is 800, 1,100, etc., etc. What I want to draw your attention to is the circled row that has both real GDP is 2,000, and at that point, our planned aggregate expenditures are also 2,000. And you say, oh, that's kind of neat. Well, let's think about why that actually happens. Okay, this is due to the role of inventories and unplanned investment spendings. Here's a virtual or a visual of what we just put on the table, right? Here's a visual of the graph. Notice that planned aggregate expenditures is on the Y and real GDP, I'm not sure if you can see that, but real GDP is on the X. And we graph this. Okay, for any value of GDP, what's our planned aggregate expenditures? That's taking the first column in the left and the last column on the right and graphing them. And what I want you also to know is that the planned aggregate expenditures, notice that it's perfectly parallel to the consumption function. It's just shifted up by the amount of investments, planned investment spending. That seems pretty intuitive, right? So what we can do is draw this 45-degree line that goes from 0, 0 up at a 45-degree angle. And what I want to mention to you is the 45-degree line are just XY pairs that are equal. X is equal to Y. So for instance, 1, 1, 2, 2, 2,000, 2,000, 3,000, 3,000. So that's what that 45-degree line is representing. And what you can see is where it intersects that 45-degree lines is where our Y value, the 2,000, is equal to our X value, which was also the 2,000. So this is visually how you find the intersection or the equilibrium of this income expenditure model. So why is it such that at this XY pair where X equals Y, why is it our equilibrium? Well, let's see. So we have three equations, and I've bubbled them 1, 2, and 3. Number 1 is our GDP, 2 is AE planned, and 3 is going to be our investment. So we want to know when, so any proof, we want to know where we want to end up. We want to end up with why does GDP equal planned aggregate expenditures? And what we're going to find is we're going to sub in for our GDP equals C plus I, and we're going to sub in for AE planned is C plus I planned. Perfect. Now we're going to sub in the third equation to the left-hand side where we have our I and say, okay, C plus I planned plus I unplanned is going to equal C plus I planned. Now, because we can get rid of things that are both on the left and the right of the equation, we would say, okay, well, the only time GDP is going to equal AE planned is whenever our unplanned investment spending is 0, meaning we perfectly predicted how much consumers are going to buy. Now, this equilibrium, whenever we say equilibrium, it's going to imply something such as stability. And this is, again, this is a term that we borrow from physics, so take from that what you will. So let's think about why it's stability. Basically, stability means that if we deviate from this intersection point, we're going to go back to it, no matter which way we deviate. So let's do the first scenario is where our planned aggregate expenditures are greater than GDP. Well, we're going to go through that whole proof again, cross out from the other side, and we say, okay, well, unplanned investment then has to be less than 0, which that means firms are going to have less inventories than what they anticipated because consumers bought more than they thought that they were going to, bought more than the firms thought they were going to. So the firms are going to turn around next January and say, we had more inventory than we had less inventory than we expected, so we need to up our production. GDP is going to increase next year. It's not going to stay the same. They're going to respond to this fact that consumers are buying more than what they had anticipated. So this is an expansionary period. So GDP is going to increase back until GDP is going to equal AE planned. Second case, well, let's say then that AE planned is less than GDP. Cross out, find that our unplanned investments are greater than 0. So that means that you have more inventories than expected because consumers weren't purchasing as much as you anticipated. That means we're in a recessionary period, and then GDP, they're going to respond, and GDP is going to fall until GDP is going to equal planned aggregate expenditures. So this is a brute force proof where we're saying, okay, let's just consider what could happen and how are the firms going to respond. If we're not exactly at the equilibrium, if we're too far to the left or to the right, we're going to end up going back towards that equilibrium regardless of what case we're in. So this is why it's an equilibrium and it's a stable equilibrium. And the 45-degree line, we can say it's just these XY pairs, but what we also want to recognize is that it's called the Keynesian cross. Okay, so here's a slide that just helps you remember what the 45-degree line means. It just means that our GDP equals planned aggregate expenditures. Our X value equals our Y value. And here, notice, I'm betting that my face is over top of my note here, but notice what values are on the X and the Y axis. I have them highlighted there. GDP is on the X, real GDP is on the X, and planned aggregate spending or planned aggregate expenditures are on the Y. So now it's not so much that we can identify the equilibrium, we also want to know how we can tweak the economy to get us to that equilibrium. So for instance, what if our equilibrium output is below the full employment level of the output? Well, we have to change our autonomous spending, right? That's what we started this chapter talking about. So it's going to have a multiplier effect, right? One person's spending is another person's income, and so on and so forth. So what we have here is our equation from the first part of this chapter that says the change in GDP is going to be equal to our multiplier multiplied by our change in autonomous aggregate expenditures. Let's do an example. Okay, this builds on the table that we filled out earlier. Assume that the MPC is 0.6. You can derive that yourself if you'd like. Let's say our actual output is $2,000, but what we want for full employment, what we would consider full employment, is $3,000. So what do we need? We need GDP to go up by 1,000. How are we going to get that? Well, we need our change in GDP, and we need our multiplier. Well, we know the change in GDP. The multiplier is going to be 1 over 1 minus the marginal propensity to consume. And that turns out to be 2.5. You can see that on the slide there. I walked you through there. Grab your equation that you need. Change in GDP is going to equal the multiplier times the change in AAE. And you find that we are going to need to increase our autonomous aggregate expenditures by $400. And what that's telling you, if you increase your spending, your autonomous aggregate expenditures by $400, GDP is going to go up by 1,000 via the multiplier effect. So here's a picture from what we found on the previous slide is on the far left there. It says, okay, we're going to shift the AE planned function up by $400. Okay, where we started was the pink dot, the light pink line with the pink dot at E1. And we said, okay, well, we want ourselves to get to the 3,000 mark. So in order to do that, we want to get to 3,000, 3,000. And what we found is that increasing our increasing our autonomous expenditures by $400 will get us back to the XY pair such that X equals Y at 3,000, 3,000. So in the future, what we're going to call these government policies, so we just said we're going to shift it. That's all I told you, is that we're going to shift it. But in the future, we're going to talk about things such as fiscal policy, which are going to be policies that are aimed at shifting these autonomous expenditures. Now, this income expenditure model, as we were talking about it, consumer spending is kind of stuck. We don't see a whole lot of change in consumer spending in response to these booms and busts. It's kind of a stagnant number, and economists tend to think that that inventories can show us or tell us a lot about what the economy is doing. It can either tell us that it's expanding, meaning that people are buying more than what we were expecting at the beginning of the year, or it could be indicating that it's contracting and we're going towards a recession, meaning that people are buying less than what we thought that they would. So I would highly recommend that you go back through all your slides, make sure you know all the equations, and give your homework a try. I hope this video helps you. If you need to get a hold of me, I will be in for most of spring break via email. If you need any sort of assistance, send me a screenshot of your question or the problem on the homework, and I'd be more than happy to send you a nice little paragraph. I hope you are all enjoying a restful break, and I will see you all in a couple weeks.